I started it.
Oh, okay. Hi everyone, we're from Walton Robotics, and today is just gonna be over SystemCore, the new 2027 unit that's gonna come out. And yeah, so for quick introductions,
Hi guys, I'm Sohan Sheikh. I am a current junior in high school, and this is my second year on the team. My role on the team is I am a assistant chief programmer. I assisted in coding multiple of our subsystems on REEFSCAPE robot, our 2025 robot. I played piano for 8 years. I'm an avid biker, and I was in the top 0.109% of all Marvel Rivals players.
Hi guys, my name is Alexandra Ding. I'm also a junior and I'm the assistant chief programmer. I was a former FTC mentor and I also helped assist in the coding of our 2025 robot. I love cats, I ice skate, and I've been to more than 10 countries.
hi everyone, I'm Rayhan. I'm our Chief Program and Programming Director. I've been on strategy for 4 years, and I've done a lot with FLL outreach on our team. I play guitar, I do taekwondo, and freshman year I used to be on the mechanisms. So for a quick brief overview of our team, we're from Walton Robotics again. So to give a quick, overview, here's our mission statement. The mission of Walton Robotics team is to help students develop personal and professional skills, inspire students to pursue careers in science, technology, engineering, and mathematics, STEM, promote STEM as a fun, rewarding, and a pathway to a brighter future. So for some quick facts, our team in 2026, it will be our 17th anniversary, and we've been to Worlds 12 years in a row. I'm not going to go too much more in depth on our team because I want to get started with the system core information, but yeah. But in case you can recognize some members, this is our team photo from last year. You may be able to recognize some of our drive team or chief programmer from last year. This is our robot, and this is Cambot, in case you've ever seen it during comp. So time to get started with SystemCore. So what actually is SystemCore? SystemCore is the future robot controller replacing the RIO. The RIO's been the leading robot controller for almost a decade now. So SystemCore is bringing many new features and improvements that is actually substantial enough to replace the RIO. We'll get more in depth on that in a later slide. But the developer and creator of SystemCore is Limelight, and Limelight, in case you didn't know, is also famous for the cameras and vision system. And another main goal of the system core is to making a team easier, whether it's FRC or later when they're making the FTC unit. Here's a quick size comparison. The system core is to the left and the RIO is to the right. And yeah, as you can see, it's substantially, smaller. So yeah.
All right, so why do we want to replace the system core with the RoboRIO, or other way around? Why do we want to replace the RoboRIO with the system core? So one of the main things that changed between the RoboRIO or the RoboRIO and the system core is that we switched from a dual core processor to a quad core processor, meaning that you can process things a lot faster and you're able to run things like autonomous periods, vision processing, and a lot of other things like that a lot smoother. Another thing that it has is the built-in inertial measurement unit, and this allows for easier use with odometry and localization, which can help teams figure out where they are on the field. But again, you'll still need more components than this. You'll have a built-in Limelight Vision processor, which means that for teams that cannot afford something like that, they are able to continue to use vision on the robot. Rayhan over here will get into more of the ports, but you have CAN FD ports, Smart I/O ports, M.2 AI ports, and dual band Wi-Fi. And one of the big things about this is that the system core is much smaller than before, and this allows for easier placement on the robot, and you can save a lot more space. And a little bit of space on the robot goes a very long way, and it's designed for flexibility and team usability. Since there is things like on-robot coding and block coding, you're able to have teams that don't know as much of Java, C++, Python code on the robot, and you're able to let them do that easier.
So to give a quick brief overview of the ports, as you can see, this is the system core diagram. It's 5.3 inches lengthwise and 2.8 width. It's also 1.1 inches thick, so it's about the size of a small smartphone. And as you can see from the port diagram, there's one power input, 5 CAN FDs, one Ethernet, two I2Cs, four USB 3s, and one RSL port. And then on the next slide, we can see the other ports that are there. So the USB-C port, motion core bridge. Motion core is another thing being developed with SystemCore, but we're not going to go too in depth with that since this is just for SystemCore. We also have 6 smart I/O ports. So the SystemCore also comes with some integrated hardware, as Sohan touched upon before. There's a built-in IMU for use with robot odometry and localization. So basically helps the robot know where it is in 3D space and orientation. We also have an M.2 A+E port compatible with Halo 8 AI accelerator. So the Halo 8 AI accelerator is also being developed by Limelight. So they're combining their other technology with SystemCore since they're also the developer for SystemCore. And the SystemCore also comes with the Wi-Fi wireless radio, but you can't use it during competition. You can only use it outside, so either at a practice field, at demos, wherever you want, but just it cannot be during a competition.
Okay, so for the SystemCore UI for the hardware, you have 3 main lights. There's a power light, mode, and status. For status, it'll blink different patterns to signify different things. And along with these 3 lights, you also have a little display here that'll show the various statuses of things that are connected to it, such as CAN, RSL, and like any devices connected through USB. For the software, the main focus for SystemCore was to lower barriers of entry. So for example, they made block coding a more viable option. Previously for FRC, there was block coding, but it was just never really used and no one really went into depth on how to use it, and it wasn't really easy to access. It also unified FRC and FTC software, which makes it a lot easier for an FTC team to transfer into FRC. And this really helps us because, as you know, we have a pipeline for FTC team that feeds into our team. So students on that team, it's a lot easier to transition. To go more into depth on the software, and this is the web interface that I believe Soham might have mentioned previously, we have on the home page VS Code, block programming, Elastic, and terminal, and you can also add any other additional packages that you would like. So if we go into the terminal, it's just a very general terminal that it shows, and it opens up on a different tab. And then if we go back to the home page and open up the Elastic, as you can see, it looks very similar to the Elastic app that you can get on your own computer. And so that just also makes it easier to access for teams that don't want to download it or aren't able to. And then VS Code and block programming, as you see here, they both will give you this little message that says it's currently under construction, which means it's not yet fully functional, but it will probably release sometime soon. And then if we go into the general data section, there's a little drop-down menu here. And so one of these options is hardware snapshots, which just shows information of like different hardware components. So you can see the temperature of the robot, the CPU percentage that's currently being used, RAM percentage, and the battery voltage as of now. And you can also see what digital inputs are currently being used. And then another option is package manager, which just shows what other packages you can use for SystemCore. And then for network and CAN, it shows the information of the CANs connected and different other devices on the network. So as you can see here, you can see like, oh, the status of like CANs and like the USB here. For interrupts, which is yet another option, it shows the interrupts. For process monitor, it shows what's being currently processed on the monitor. So all these names are also pretty self-explanatory, which is nice, and it makes it a lot easier to navigate. For services and logs, it shows the logs, but it's not your general advantage scope logs. It's the more nitty-gritty hardware logs. And then for kernel information, it shows the information about the kernel of the OS, which would, for in our case, would be SystemCore. And then camera is still currently under construction. For this feature, it appears to be something that scans, but we're not 100% sure since it's also still under construction and we haven't been able to test it out yet. For settings, you can just set your IP address, your network, your Wi-Fi SSID and password, and all other major network items. You can also update your network configuration.
So our main task, being 1 out of 37 US teams, 1 out of 50 internationally, was to verify that SystemCore actually will work on a robot and verify that the hardware will not, not work. So hardware meaning motors and stuff like that. So with installing the SystemCore on a robot, the physical installation was actually not that hard. The main thing we had to do was obviously transfer the stuff connected to the RIO to the SystemCore. But other than that, the main challenge was in the digital inputs. So RoboRIO DIO is internally pulled up, whereas the SystemCore one is internally pulled down. So the main issue is that SystemCore used sourcing, which was very annoying, and required us to adapt our wiring to work with digital inputs of the SystemCore. So since the sensor that we are using for the input on the robot is designed to work with an input that's internally pulled up, we had to add an external pull-up resistor to be able to use it with the SystemCore, and that resistor is 2,000 ohms. The total installation time was around 4 hours, but half of it was with the digital inputs. So this is SystemCore in a robot. As you can see to the left image, this is a closer up view of what it actually looks like, when it's physically installed. But to the right, you can see like the size comparison with the Rio and how much smaller it actually is and how much better it is in terms of, finding space to put on your robot. And now for the software implementation, again, our main task was to verify hardware functionality. So to do this, we needed to import our competition code from Worlds last year to 2027 WPILib. And as upgrading to any higher version of WPILib, you needed to ensure that the method names were corresponding properly. So we had to check the APIs to check which method names changed and change them to the newer versions. We also had to install new vendor deps, again, for 2027, except we'll get more into this one later, but Photon Vision wasn't quite out yet when we wanted to install it. But other than that, CTRE and Choreo were ready to go. For generic entries, basically, we're going to get into this later also, but generic entries were no longer supported. They had to be type specific. And for Smart Dashboard and Shuffleboard, since it is simulating for 2027, both of them have been deprecated.
Okay, for the Auton chooser, as Rayhan previously mentioned, Shuffleboard and Smart Dashboard was deprecated, which we use for our Auton chooser. And so here, as of now, is what our Auton chooser currently looks like. So as you see, it's very simple, it's very easy to use, and we want to make it as simple as possible to minimize user error. And this is the code for our Auton chooser before and after we change from 2025 to 2027. So as you can see here, we have a lot of generic entries, which, as Rayhan previously mentioned, no longer existed. And here we change it to pub subs, which are what is compatible with Elastic.
All right, so one of the main issues that we had with changing the code that bothered us was the controller D-pad handling. So it's a pretty funny story, but the D-pad POV handling changed. So previously, up was set to the value 0 and nothing was set to the value -1. But now it was set to nothing being 0 and up being 1. So on our robot, we use the D-pad values to control which heights our robot goes to. And fortunately enough, L4 was set to the value of 1, or 0 rather. And this meant that whenever our coral would go fully into our coral chute, our robot would shoot straight up to L4. Now, this did cause us quite a bit of problems. Our intake broke off here, as you can see in the photo. And what we had to do to fix this is we went straight to WPILib after about a day of testing, and we talked to them about it, and they said it was an issue on their part. So they sent us a fix, and we were able to, they sent us a fix, and they were fixing it in the next release.
Okay, so for the wheel alignment code, we wanted to create a serve drive wheel alignment code that was custom for Elastic, but however, it relied on Smart Dashboard. This is an example of what the custom widget should have looked like. And here's the snippet of the example code that we would have used. And as you can see here, it uses Smart Dashboard and Cinnable Builder, which, as we learned, was deprecated and had not come out with a 2027 version yet.
So as Rehan previously mentioned, Photon Vision wasn't able to implement at the very start of the beta. So what we had to do was wait for a bit. Photon Vision was very understanding with us. They were able to talk us through how to install it once it came out. So what we had to do once we installed it is we had to change our IP from .200 or 10.29.74.200 to 10.29.74.2 in order for the vision camera to work and us to get auto align working. And here we have a video of the auto align actually working.
You take it?
On NTC Cafe.
TC kickoff happens.
And now that we're done speaking about all the system core information, we have a small clip of our system core robot in action during Autumn. And yeah, that's the end. So if any of you guys have any questions, we're also joined by our programming and engineering mentor, Banks Troutman, so he should be able to help out.
I don't see any questions. Do you want to end the meeting?
Yeah, I think we're good.
Okay, thank you.
Thank you.
Thank you.
Thank you.